Another example of a unit analysis problem can deal with density. And yes, you can solve these problems using the density equation that you've learned a long time ago. That's a totally fine option, but I'm going to show you how to do this type of problem without that formula and just keep using the unit analysis process so that you can kind of see how the same process can be used in many scenarios. So here you're given the density, but the question is, what is the volume of 1 penny? Well, that's the question, so I want to start with 1 penny. In the end, I want to end with a volume unit. Well, volume units could be cubic centimeters, they could be milliliters, but typically for a solid like a penny, you would end in cubic centimeters. So I'm going to work with these units and try to keep canceling the units that I don't want and get to the units that I do want. So for instance, if I have 1 penny, on my next factor, I want penny on the bottom. And in my information, it told me that 1 penny has a mass of 3.16 grams. So penny cancels. Then I'm in units of grams, but I don't want units of grams. I want centimeters cubed. So on my next factor, I'm going to put grams on the denominator. And it says that 8.933 grams is equivalent to 1 cubic centimeter of copper. So grams cancel, and you end up with cubic centimeters. Lots of people don't like this because they always say, well, up here grams are on the top and cubic centimeters are on the bottom. It doesn't actually matter. This is an equality. If you have this many grams of copper, you would have a volume of 1 cubic centimeter of copper. So you can put either one on the top and either one on the bottom. They are equal amounts. So just because it's written like this doesn't mean it can't be switched around, because it's still an equality. It's an equal amount that can go in this factor. So when I calculate, don't put ones in your calculator. 3.16 divide by 8.933. It ends up being the same thing that you do with your formula over here. And you can have the number of sig figs here is a little tricky because 1 penny is not a measured value. You didn't get out a ruler to measure 1 penny. It's an exact number. So you can't use sig figs with just 1 penny. So then you would probably have to go by the either the mass amount or the density amount. The mass one gives you less, which is why we get the 3 sig figs.